us through video conferencing is one of the most influential minds in artificial intelligence today. Someone who has contributed in shaping the very way we think about machine learning, data science, and education. Ladies and gentlemen, put your hands together to welcome Mr. Peter Norvig, Director of Engineering and Education Fellow, Google and Stanford Institute for Human-Centered AI, to shed light on AI applications for business now and in the future. Sir will be joining us through video conferencing. Come on, but he still has to hear you. Give him a big round of applause.
Okay. Thank you for that introduction. Are we ready to go? Right. I'm glad to be talking to you. I'm sorry that I can't be there in person, but happy to participate by video. And I want to talk to you about where AI is today and where it might be going. First, let's start with some of the bad news. This report came out a few months ago saying 95% of generative AI pilot programs are failing. That seems pretty bad. So we want to figure out how you can avoid being in that part. Now, some of it isn't as bad as it seems. When they said failing, what they meant is not showing a positive return on investment within a 6-month period. And there are other criteria for success. And there are other studies that have quite different conclusions. So at Stanford, we put out this AI index every year. And here, there's dozens of studies, and many of them look really good, getting 5%, 34%, 12% improvement. A couple of them not so good. 0% improvement on a task where the best people were already perfect, so they couldn't improve. And a negative score on a task where people found the AI so interesting that they ended up playing with the AI rather than doing their regular task and lost some time. But maybe we can think of that as an investment for the future. Here's a study that says, on average, people are gaining about 2 hours per week from their use of generative AI. So a small but important gain there. So how can you be in the camp that succeeds rather than in the side that fails? And I think the most important thing is to remember that AI is not a regular information technology implementation. You don't just go and buy some software from some vendor and install it. Instead, the best uses of AI come from the bottom up. They come from the workers who have a task and can say, here's the hard part of the task, here's where I need some help, and AI can help them. So we want to make sure that you know from the start, this is what I'm trying to accomplish. Don't just say, I got to have some AI because everybody else has it. Say, here's what I need it for, and here's how it can help. Then it's really important to provide training and support to people so that they do a good job on it. AI runs on data, so making that data available, stopping the temptation to keep everything secret, make sure you share it. And then think about optimizing processes, not necessarily looking for revenue immediately. Because if you make things better, then the revenue will follow over time. Really important to understand that problem solving involves contact between multiple people. So don't silo them. Make it everyone's business to do a good job with this. Now, I want to talk about this, what I call the personal computer non-revolution. So there was a personal computer revolution. And why do we get that? Because we had things like the spreadsheet, and we said now an accountant who used to take minutes to add up a column of numbers can now do that in a second. So that should make things much, much faster. But if we look at this, and here's a chart of GDP growth by percentage in the US over the last 90 years. And I look at that chart and I see two big events, the Great Depression and World War II. But other than that, I don't see much. And right there was the introduction of PCs, and you can't see a big impact from that. Now, I thought about why could that be true? And in computer science, we have this thing called Amdahl's law from Gene Amdahl, who was the founder of one of the most important supercomputer companies. And he said, supercomputers can really help. You have lots of processors, you can do things lots of times faster. But if the part that you speed up is only a small part of the problem, then you can only make a small improvement. And I think that's what's happening with accountants. Yeah, it was fantastic that they could add up this column of numbers instantly, but adding up columns of numbers turned out to be not a big part of the accountant's job. The big part was figuring out where those numbers should go, what column they should be in. And spreadsheets didn't help with that. Now, AI is a technology that's much more general, and it may be able to help with things like that. So we could see a big speed up. And how big? So to get an idea of that, I'll compare the GDP growth in the US and China going back to the start of the century. And in the US, we see it's pretty flat. China, they were up at 10% GDP growth around 2010. And why was that? I think it was because they delayed the impact of technology. They didn't have personal computers in the 70s and 80s. They kind of waited. And they waited for the technology to mature and the ways of using them to mature. And then they kind of reaped the benefits all at once. And that's how they were able to get up to 10%. And then as that saturated their economy, it started to come down because they'd already seen the main benefits. And so I think that the impact of AI technology could be similar. Could see this as something that we're harvesting all at once, because look how fast AI is moving just in the last couple of years. So it feels like it could have the same kind of impact that digital technology had on China. I was at a conference recently that combined AI people and economists, and they asked, what do you think GDP growth is going to be 20 years from now because of AI? And the median answer was about 10%, but the range was everything from 1,000%, which seems impossible, to the complete destruction of civilization, which also doesn't seem very likely to me. So economists just don't know where we're going, but this is my prediction. Now, I want to talk about this idea of hierarchical organization. Say you have this nice hierarchy, and somebody here comes up with a report, hands it up to their boss, but the boss says, well, that's not interesting, so I'm just going to file that away. I'm not going to pass it on to anybody else. And then somebody else does the same thing and gets the same result. And I put these names on here because this actually represents something that really happened. So in 2001, two operatives at two field offices of the FBI in the United States, in Minnesota and Arizona, filed reports saying there's something going on with people in flight schools, and maybe they're doing something they shouldn't. And both reports were shelved because the organization had this idea that we're hierarchical and we like to have secrecy, so they never got together. And if they had, then maybe somebody would have said, looks like there's a concerted plot going on. Maybe we can stop this plot before something terrible happens. So we don't want to have hierarchical organizations like this. We want to embrace the idea that there's uncertainty. Somebody writes a report, you don't know if it's right or not. We want to encourage communication. Don't hide things away in secret. Share them as much as you can and build ways to find connections. Now, in a small company, it happens by people sitting around the water cooler and talking to each other. But in a big company, that won't happen. They won't find each other. So we have to use technology to find two people in very different parts of the company who have ideas that should come together. And that's why we want a networked organization, which is flexible, stresses collaboration and communication, and exaptation, which is a word from the theory of evolution. And things like feathers were originally designed to keep animals warm, and then they were adapted for a new purpose of flight. And I think that's the way that a lot of breakthroughs come, that it's not somebody says, you're going to do this project and we're going to, here's the specification, we're going to take it through to the end. It's you come up with one idea and then later you use it for something else. And that's how innovation happens. And network organizations have to do that. But as they get larger, they need help. And that's exactly where AI can play that role, that it can take this data that's messy and say, here's two ideas, they seem to go together, let's put them together and innovate something new. So we have a lot of ways of storing this information, right? So we have databases with structured data. We have data science that's designed to let us explore and visualize unstructured data. And we have generative AI, which allows us to understand and exploit all the data of all different kinds. Who gets to do that? Well, the databases is mostly the corporate database admins, and then they allow the users in. In data science, it's usually departmental data scientists. But in generative AI, we can build these systems so that anybody can use them. You don't have to learn fancy SQL commands. You can just go ahead and do it. Now, in terms of business applications, I want to look at a couple of them: fraud detection, credit scoring, algorithmic trading, customer service. And I think there's a lot of use of AI here. And generative AI is helping, but we've also had sort of old school machine learning and data science in these fields. So for fraud detection, you can do supervised learning. Here's the cases that are okay. Here's the cases that are flawed. Now let's predict a label on a new one. So we can do that. Part of the problem, though, is that if you detect what the bad guys are doing, they're going to stop doing that, and they're going to do something new. So supervised learning learns something that may no longer be useful in the future. So we can use these other approaches of clustering, and deep learning with autoencoders does an excellent job of representing transactions and allowing us to detect new kinds of behaviors, even though we haven't specified that ahead of time. And we can look at various kinds of biometrics and user profiling. This user tends to do this thing and this thing and this thing. Now here's something comes in that looks different. It's an anomaly, it could be fraud. And these technologies of graph neural networks work great for that. So we started off, language models use these linear networks, one word after another, and graph neural network says there's lots of connections. So we can detect, say, a syndicate that's doing money laundering. For credit scoring, AI is really good at finding these complex nonlinear patterns. And modern generative AI is good at using unstructured data. And that's really important, especially in developing areas where people may not have a lot of bank records and transactions. You can look at other data that's available for them. So, for example, making use of imagery. Someone doesn't have home ownership or a record of apartment renting, but you have an aerial view of where they live, and that gives you some idea of where they are and how trustworthy they might be. And the use of AI allows you to go faster so that you can track your customers and you can update their score even after a loan is granted. You can say, are they going up or down? And then decide, do you have to interact with them to fix that? Algorithmic trading is really interesting. The transformer technology that we use for large language models is really good at time series analysis, one event after another. And using it means there's less need for feature engineering. It used to be that an analyst had to go in and say, here's all the attributes that we're looking for. Now, if you have the right data, AI can sort of pick that out without a lot of human interaction in the loop. The traditional methods still have value, but these complex cross-correlation can be done with the newer generative AI approaches, and they can incorporate different signals than we've seen before, right? So we don't want to just know for each stock what's going up or down. We also want to know what are people saying about that. So let's do sentiment analysis. Let's read all the news articles, all the social media, and make sense of that and combine that in with the numeric signals, which is something we can do with generative AI. It was harder to do before. Customer service is a fantastic application. Conversational chatbots are always available, and they can be personalized and proactive. I had a really bad experience just the other day where I was on hold for 45 minutes, and you almost lost me as a customer when you do that. But if you can answer instantly and know who I am, know my whole history, give me a personalized summarization, and resolve my problem quickly, then I'm going to be a happy customer. And we can also do things like triage. So you can have an AI system that handles most of the interactions with customers, but knows when something is unusual and we really ought to hand it off to a human expert to solve it. And then additionally, this idea of root cause analysis. So you've got a lot of people in the customer service room. They get really good at solving individual cases, but they may not be able to see the big picture and say, here's what's going on across multiple cases. Now we have a solution for that. And I was asked to talk about the application of quantum computing. I think that's really fascinating. If you'd asked me 5 years ago, I would have said, I don't need to know this because I'm going to be dead before it works. Now I'm not so sure. And we're in this funny stage right now that they call the noisy intermediate scale quantum computing era, where we can build these machines with a couple hundred qubits, and they're noisy and they're not fault tolerant, and they can't solve the problem all by themselves. But what they can do is get us started and set up the problem so that we can then pass it on to a classical computer, which does the difficult optimization step. And we're seeing these methods improve as quantum computers advance. So I think in the near future, this will be common. And how do we make it work? Well, it's going to be important to have the expansion of cloud access to these quantum computers and have that be cost effective, because it's really hard to build your own. So really need to access it through the cloud. That's not generally available yet, but I think it will be soon. Getting the error correction threshold down is important. And there's going to be lots of exciting new applications in chemistry and in optimization and so on. And eventually, we'll get to this era where we can build bigger computers that can do the whole thing on their own. But it's going to take a while till we get there. Okay, so what do we learn from all this? So again, I think one of the keys is that AI is not regular IT. Don't think of it as putting in a big implementation. Think of it as providing tools that all your users can use and figuring out a way to encourage them all to use it and for them to say, how can I make my job better? What products can I invent that we haven't seen before? There is going to be uncertainty, but accept that and deal with it and encourage communication across the team, because having innovation comes when two different people are seeing something, seeing a problem from different angles and putting that together and coming up with a solution and using AI to help solve it. So that's where I would put my emphasis in trying to bring my team along, trying to get them to embrace this new AI era. And if you can do that, I think you'll be in the percentages that are successful and not in the ones that are failing. So why don't I stop now and we can open it up for discussion, and there's a QR code for these slides.
Thank you so much, Mr. Norvig. Your reflections on the now and next of AI remind us just how fast this field is evolving. Ladies and gentlemen, the floor is open for any questions. Would anybody like to raise their hand, ask a question? We have a gentleman there. Can we send a mic to them?
Hi, thanks for the opportunity. My name is Prakash. I'm with Fitch Ratings and a student researcher at Binghamton State University, New York State University. So I am studying neural networks right now and just curious about the state of the art of some of the models that we're using to predict defaults or risks in the financial system, some of the work that was earlier talked about. What I want to understand is, given what the state of the art is today, is it more probabilistic in terms of trying to predict the future based on the past? Or is it already something that's understanding the mechanisms that drive risks in the system? That's my question. Thank you.
Yeah.
From anyone who's willing to take it.
So certainly thinking of it as probabilistic, I think is the right way to do it. You know, if it was deterministic, then somebody would have solved it already, right? So it's hard to predict, especially the future. And in these financial markets, it's especially hard because it's adversarial, right? When we're trying to do physics or chemistry or biology, it's hard because there's a complex world out there that we have to model, but we don't feel like the world's going against us, right? Trying to understand how a protein folds. AI was able to solve that problem, but the proteins didn't change because it felt like AI was after them. In the financial markets, there are lots of people that are acting in adversarial ways. So we're never going to be able to be perfect at predicting what they're doing. So think of it as being probabilistic. It's saying we can do a little bit better than if we had less knowledge and less computing power and less data. And so we can try to predict the future as best we can. Another way you can win is by what we call predicting the present. So if you can just look at data and figure out what's going on right now faster than anybody else can figure it out, then you can take advantage of that. And there are various ways in which you can have that to your advantage, and you don't have to predict the future. You just have to understand better by processing data where we are right now.
Thank you so much, Mr. Norvig. Do we have any other questions? We have one more question, and there you go. We can't hear you. Just a second.
Check.
Hi, am I audible now?
You can be a little louder.
Okay. Hi, I'm Shubha Sharma. I'm ex-Deloitte, ex-EY, and ex-HSBC. And I have sort of spent my life in the area of risk strategy and regulatory compliance in the BFSI sector. I currently own a startup, and we are launching Complifier.ai. So given my background, what I heard from Peter, sir, there was one statement that sort of puts me on the edge, where when he spoke about what the senior management should be looking at in terms of strategic imperatives, he said that do not be shy in sharing data, freely share, do not be secretive. So that is where, you know, a risk and compliance person would be very edgy, and I'm not sure where to draw the boundary and what are we dealing with here. So please do elaborate.
So great question. And certainly, you know, I didn't mean to imply that you shouldn't worry about privacy and security. You need to have that. And if you have customers' data, you have a responsibility to protect that to the utmost. I guess what I thought more about was people thinking about your own business and coming up with ideas and making it easier to share that. Now I have a friend who got the job as a knowledge officer at Schlumberger, the oil company. And for them, they said, we're a big international company, we're all over the world, we got lots and lots of employees, and sometimes we really have to know who has the expertise, right? So like an oil well is on fire in a particular way, and somebody in the company knows how to put that fire out, and until you contact them and they tell you how to do it, you're losing $100,000 an hour or whatever. And so they built the system and encouraged everyone to say, sign up for this system, write down what you know, write down who you work with and what your connections are so we can assign you to the right teams. And it was hard going. There was resistance to that. People said, I don't want to do this. I got a job to do day to day. Why do I want to add to this knowledge base? And one of the things he did that really turned the tide was going to upper management and convincing them to say, let's put participation in this knowledge base into the annual performance reviews. And when they did that, all of a sudden, people started to participate and they could measure how much better communication was, and there was a real impact to the company. And I think the reason people participated, well, there was kind of two. One was, okay, they said they wanted to do this. If I do it, maybe I'll get an extra bonus or I'll get a raise or something, or it'll be a little bit of positive that'll push me forward. But I think more important to that, what it said to people was, management is telling me all these things to do. They got like a dozen memos of things I should be doing. But this one, they're putting money behind it. That means they must really care. And if they really care, then I'm going to participate and I'm going to take this program seriously, and I am going to share the knowledge. And that made a big difference to that company.
Thank you so much, Mr. Norvig. It is a privilege to learn from you how essential it is to stay curious, intentional, and human in our